morning, dear students. Now we will come to the next point today, the next portion of the same chapter. We'll discuss the three things. One is the laws of liquid pressure. Second one is the consequences of liquid pressure. And the third one is the Pascal's law and demonstrations of the Pascal's law. Now the first one is the law of liquid pressure. Altogether there are 5 laws. So to understand about the first law, you take 2 vessels, container, and fill them with water. The first vessel you will fill the less amount of water so that the height of the water level will be less. In the second vessel, you fill more amount of water, that means you fill the entire vessel, you fill with water so that the height of the vessel will become more. So there is a difference in the height or difference in the weight, depth of the water level in the 2 vessels. Now the first law, it states, inside the liquid, the pressure increases with the increase in depth or height. That means when the liquid is inside a container, okay, or in a confined liquid in a container, the pressure increases with the increase in the depth. When the height or depth of the liquid will be more will be the pressure. So the first law, inside the liquid, the pressure increase with the increase in depth from the free surface. So free surface means the surface which is above the water level. Just above the water level, that we call it as a free surface. And even the free surface also, the pressure will be accelerated here. I have already discussed that, which we call it as atmospheric pressure. But inside that, below the free surface of the liquid, the pressure will be accelerated. And the pressure will become more, or pressure increases with the increase in the depth. So that means I have drawn here, that means this is the diagram here. I fill this container with the water, with the liquid here, and this is the height of the container, height of the water. So in that case, the first vessel which you fill with water, the pressure is less because the height is less. In the second vessel, the water which you have filled more amount of water. That means you have filled the water up to the neck of the vessel. The level of the water is more. So in the second vessel, the pressure will be more. So that means the first law, it states that inside the liquid, the pressure increases with the increase in depth from the free surface. Second one, in a stationary liquid, when the liquid is not flowing, in a stationary liquid, the pressure is same at all the points. So that is everywhere inside in a stationary liquid, the pressure is same at all the points. That is the second law. And the third law is here. Pressure is same in all the directions. Again, the pressure is same in all the directions at all the points. Everywhere the pressure will be same. And the pressure exerted by the liquid is same in all the direction is demonstrated, or this was proved by Blaise Pascal. Blaise Pascal, he was the French physicist. So he demonstrated that the pressure exerted by the liquid will be same in all the direction in a confined liquid. Confined means the liquid which has been placed in a container, okay, in a vessel, the pressure will be same in all the direction. That is the third one. And the fourth one is there. Pressure at the same depth is different for different liquid. Okay, pressure at the same depth is different for different liquid. That means you take a 2 liquid, one is a fresh water, other one is a salt water. And the fresh water and the salt water, the depth or the height of both the fresh water and the sea water is same. The height will be same, but the pressure will be different. Okay, the pressure of sea water will be more than that of fresh water, because the sea water has got more density because the presence of salt. The dissolved impurities or the dissolved salt are there. So because of the dissolved salt, the density is more. So therefore, the fourth one is here. At the same time, the pressure will be different for different liquid. So this pressure, this difference in the pressure is because of the density. So more the density, more will be the pressure. Since the seawater has got more density because of the presence of salt rather than the fresh water, the height are same, the depth are same, but the pressure exerted by the seawater will be more. And the last one is there, liquid has its own level. Liquid 6 is its own level. So these are the 5 laws related with the liquid pressure. And the second one is the effect of liquid pressure. Consequences, various consequences are there. Number one consequences is, number one effect is there, the base of the dam. When the dams are constructed, the base of the dam are made thicker and wider. Because wider means the surface area will be more. More the surface area, lesser will be the pressure. You know that. Then again it is made thicker also. And this thickness of the dam increases from the top to bottom. When the dam are constructed, okay, the thickness will go on increasing from height according to the height. That means that thickness will increase from top to bottom. Now when the thickness will increase, okay, what will happen at the greater depth or greater height, the pressure will be more. The pressure exerted by the water will be more. So in order to withstand that greater pressure exerted by the water, the base of the dam should be made thicker. So this is the reason why the base of the dam, when the dams are constructed, the base of the dam are made thicker as well as they are made wider, in order to withstand or in order to prevent from the pressure, enormous pressure to be exerted. The second one is here, water supply tank is placed at a height. At home, you keep the water tank on the top of your house, on the terrace, okay, on the roof you will keep it. Now why you keep is that the flow of water will be the flow of water. That means when you keep at a greater height, at a certain height, when you keep that water tank, the pressure exerted by the water will be more. Because greater the height, greater will be the pressure, more will be the pressure. So when the water tank is kept at a greater height, the pressure exerted by the water will be more and the water will flow freely through the taps. Okay, the water can flow freely, so more amount of water can flow. So that is why the water tanks are placed at a greater height. Third one is here, diver's suit. Okay, diver's suit means when a person, that means when people when they go underwater, under seawater, sea divers we call it. When they go under seawater, okay, they have to wear a special suit, which we call it as a diving suit. We call it. Okay, you cannot go without wearing a diving suit. You cannot go under the seawater because, as you know, the density of the seawater is more. So when you go at the greater depth, when you go, enormous pressure will be exerted. Okay, enormous pressure is exerted by the sea or by the water to your body than the blood pressure. Okay, that means your body will have more pressure. Your body will exert more pressure. So in order to withstand that enormous pressure exerted by the sea water to the body, the sea diver, they have to use a special suit which is made up of glass or plastic or cast aluminum. So this will help. This will maintain the pressure inside the sea. So these are about the effects of liquid pressure. Now the third one will come to the Pascal's law. Okay, now the Pascal's law. Now this Pascal's law states that he was a French scientist. Okay, and he proved that the pressure exerted by a liquid column will be given equally in all the directions. That means the liquid will exert pressure equally in all the directions. So he stated a law, and that law we call it as a Pascal's law. Now according to the Pascal's law, it states that the pressure exerted anywhere in a confined liquid. Confined liquid means the liquid contained in the vessel or in a container. The pressure exerted in a confined anywhere in a confined liquid is transmitted equally in all the directions throughout the liquid. That means in a confined liquid, when the liquid will exert the pressure, that pressure exerted by the liquid will be transmitted equally in all the directions. So for that, one experiment is there. So for this, we have taken he has taken a flask, a glass flask, okay, and there is a narrow tube is there, which are coming from the side of the flask as well as from the bottom of the flask. Okay, there is a narrow tube. 1, 2, 3, 4, 5 tubes are there. These tubes are very much narrow. Okay, and these tubes are coming out through the walls side of the glass flask as well as from the bottom of the flask. Okay, and there is a piston here. Okay, and piston is fitted with the neck of the flask. Okay, and this piston can move up and down. You can bring the piston. You can press the piston downwards, or you can bring it up. Okay. Now this narrow glass tube is filled with a liquid here. It is filled with liquid. So that means inside the flask you fill with the water. Along with it, you fill this narrow tube also with liquid. And the same amount of liquid, the level of the liquid in 5 narrow tube will be same. That means the initial level of the water or liquid in this narrow tube will be same. So I have marked here with a line here with a horizontal line 1, 2, 3, 4, 5. Now this line represents that the liquid, the same level of liquid has been filled in a narrow tube. Now what happens is that now you put a piston. That means you press the piston or push the piston downwards. When you push the piston downwards, the water, the jet of water we call it, the water will come out through all the narrow tubes in equal level. That means there is a horizontal line again I have drawn here. This horizontal line shows the level of the water coming through this narrow tube. The same level of water is coming out. Okay, so this is shown by the horizontal line here. So when the piston is pressed downwards, water from this narrow tube will come out. Okay, and equal amount of water will come out, and the level of water, that means the amount of water which come out through that narrow tube will be equal, will be same. So that means from all the narrow tube, equal amount of water will come out from all the direction. It's not that from the base the level of the amount of water will be less. Okay, and again this tube is here, and this tube is near to the neck of this glass tube, and it's not that from here the water will come more. Okay, it's not that. Whether you fix the narrow tube to the bottom, to the top, or to the middle, anywhere you make a tube, you connect a tube here. Okay, all the water from the tube will come equally in all the directions. So this way, Weiss particle proved that the pressure exerted by the liquid will be in all the directions. Okay, so this is about the Pascal's law. Thank you.